Okay, hello and welcome everyone. In this video, I'm going to continue on and do another collection of exercises. I'll show you those in advance here, and then I'll go over them step by step with solutions. So if you haven't already got these, I'll just leave it for a second so you can take a screenshot. So I'll do question number 6, 7, 8, 9 is the same as 8 with different numbers. Let's see. And then, matter of fact, I think I actually also want to do, well, yeah, I'll do 10 and 11 in the same video. Fine, let's do that. All right, so question number 6. Anne has preferences over good x and y with a utility function given by x plus 5y. Those are perfect subs. Here's the income, 120. Here's the price of good x is 2. Price of good y is 3. How many uses does Anne consume of y specifically? Bob has preferences represented by these perfect subs preferences, consumes 10 units of x, 9 units of y. If his consumption of x is lowered to 1, how many units of x must he have in order to be exactly as well off? Here's a Kool-Aid and lemonade problem. So Bob has, I can't talk about, think of like Dane Cook and his Kool-Aid man. Anyway, so Bob has preferences given by his utility function, where K is gallons of Kool-Aid, L is gallons of lemonade. Okay, perfect subs, good. We're just saying we're going to put Kool-Aid on the horizontal. We're going to put lemonade on the vertical. Yep, I wrote it the intuitive way. Here's the income, here's the prices. Good. And then I change it. How does I change it? I put the different marginal utility. Now the marginal utility of K is 1, marginal utility of L is 2. Here the marginal utility of K is 2, marginal utility of 1 is, or marginal utility of L is 1. All right, 10. Suppose the government is interested in helping me consume coffee along with the cookies that I consider as perfect complements. My utility is standard perfect complements. X is coffee, Y is cookies. Assume cookies and coffee each sell for $1. I have $12 per month available. That's my cookie and coffee budget. Government's considering two schemes. They could either give me 6 coffee vouchers that have to be used on coffee, or they could subsidize each unit of coffee so that I pay a half price. Given my preferences, which do I prefer? Which has the greatest utility, which is the highest consumption of coffee, and which does the government prefer? Suppose Anne and Bob face the same prices. They have the income of $12 to spend. The price of Y is always 3, but the price of X is designed to discourage large purchases. $1 for the first 3 units, 3 thereafter. Draw budget set. Then, given these preferences, what do they optimally consume? All right, so and then you see number 12. That'll be in another video. All right, so question number 6. Actually, let me cue this up when I come back. Sorry, so forget about 12. Hey, spoil. No, this is what they call it. It's a tease or a hook or whatever. There you go. It's like in show business or radio or stuff like that. Come back after the commercial and you get to learn all about question number 12 and 13. Good. So question 6. Anne had these preferences, perfect substitutes preferences. As soon as I stare at perfect substitutes preferences, I immediately back out the MRS. It's going to be the marginal utility of x divided by the marginal utility of y. What's the marginal utility of x? It's just the partial derivative with respect to x, so it's the coefficient. And then what's the marginal utility of y? It's the partial derivative of the utility function with respect to y, so it's just this coefficient. It's 5. Y didn't have anything to do with x, or x didn't have anything to do with y, because they're constants with respect to the respective partial derivative. Price ratio is going to be 2/3 because we have px over py. Notice I didn't even bother drawing the budget constraint yet, or even building the budget constraint. I use income last here for these type of problems. So I'm going to compare 1/5 to 2/3. I know 1/3 is smaller than, I know 1/5 is smaller than 2/3, right? 0.2 is smaller than 0.6667. So this is an all y solution. So this is our alley solution. Here, alley, all y involves m of 120 divided by the price of good y, which is 3. So 120 divided by 3 is 40. So that's our alley solution, right? How many units of good y does Anne consume? So Bob has these preferences. He's currently consuming 10 units of x, so that's going to be 10 times 10 is 100. 9 units of y, so 5 times 9 is 45. So we'll have 145 as Bob's current level of utility, right? If his consumption of x is lowered to 1, how many units of y must Bob have to be exactly well off as before? Okay, so with 1 unit of x, so now so how are we solving this? We found that Bob's level of utility for the original bundle is 145, so I'm going to set 145 equal to 10 plus 5y. Why? Because it's going to be 1 unit of x, so 10 times 1 is 10, so it's going to be 145 minus 10 is 135 divided by 5 is 27 units of y. And then we can confirm that indeed Bob gets 145 units of utility. Sure enough. So my comment, this is really just an understanding utility and marginal utility question. That's all that is. All right, question 8. Bob has preferences given by this utility function, perfect substitutes. This is going to have an MRS of 1/2, right? MUK divided by MUL is going to be 1/2. MRS is 1/2. So what's Bob's marginal utility of Kool-Aid? 1. Marginal utility for lemonade? 2. And then what's the marginal rate of substitution? 1/2. That's this right here. Suppose Bob has an income of 24, faces these prices. 2/3 is our price ratio. Oh, 2/3 is going to be steeper than 1/2. 0.5 is smaller than 0.6666667. So it's going to be an alley solution, right? So what's all y going to amount to? Well, Bob had 24 units of income divided by the price of, let's see, we had lemonade on the vertical. Is that right? Yep, lemonade on the vertical, Kool-Aid on the horizontal. So 24 divided by 2 is 12. Okay, so my alley solution, my all y solution for Bob is going to be 0.12, which costs $24. All right, let's solve the same problem, but let's give the marginal utility of 2 to 9. All right, so now the slope of the indifference curves, the marginal rate of substitution is going to be 2. What do we do with the prices? Did I keep the prices the same? I did. This is going to be 2/3 is the slope of the budget constraint, but the MRS is 2, so this is going to be an all x solution. If you were to draw the picture, you'd see the indifference curves have a slope of 2. The budget constraint has a slope of 2/3, and so the highest indifference curve that we could attain is going to happen at the horizontal axis. That's our Alex solution, our all x solution. How much x can I afford? 24 divided by 3, which is 8. Right, that's this. M over PK is going to be the horizontal intercept for my budget constraint. That's where my highest indifference curve is going to hit when the indifference curves are steeper than the budget constraint. So it's going to be 24 over 3 is 8, all y. All right, here's this interesting one. Suppose the government is interested in helping me consume coffee along with cookies that I consider as perfect complements. Assume the cookies and coffee are both $1 each. I have $12. There's 2 schemes. One, they give me 6 coffee vouchers, or they cut the price of coffee in half. I saw this, 5 letters given pens. And out of the corner of my eyes, like that says Green Bay, so I wrote Green Bay here. That's how my mind works. So, all right, which of the 2 schemes cost the government the less given my behavior? Let's take a look at this. So, with scheme 1, I start out with 6 coffee. They're spotting me 6 coffee. So my indifference curves, my utility is going to be x plus 6 and then y, right? Because it's going to be however many units of coffee I buy plus the 6 I was given for free, right? So let's replace the comma with an equal sign. This is going to find the line through the corners of my indifference curves emanating from the origin. Oh, not from the origin, because in 0, 0, this is 6, right? And x is 0, this is 6. So emanating from, it's going to emanate from the 0.06. Sorry, but it's just, you got the right idea. So I'm going to plug this into the budget constraint. The budget constraint is just x plus y is 12 because we said cookies and coffee cost the same. So this is going to be x plus 6. I've made that substitution. Or 2x plus 6 is 12, or 2x is 6, or x is 3. So if I have 3 units of x, how much y am I going to have? 3 plus 6 is 9. Okay, so I have 9 units of y. What's my utility going to be? U of 9. Wait a second, why 9? Oh, because I have 6 units of coffee plus the 3 I bought, and then the 9 units of cookies. So my utility is going to be whichever is the smaller of this side and that side of the comma. It's 9. Okay, the other situation was, suppose they were to reduce, they subsidize the price of coffee, so I pay half price for coffee. All right, so then what I've done is I've said, all right, well, initially the price of coffee was 1. Let's make the price of coffee 1/2. Now I'm not getting any coffee for free, so my indifference curves are indeed just going to be, utility is just going to be indeed whichever is the smaller of x and y. The line through the origin collecting the corners of my perfect complements indifference curves is going to be y is equal to x. I'll plug this into the budget constraint. The budget constraint is going to be 1/2, which is the price of x, plus 1 times the price of y is equal to 12. Substituting for y, I'll have 1/2 x plus x, or 3/2 x is 12, or 2 times 12 is 24 divided by 3 is 8. That's this. So using my budget constraint to now find how much y I must consume, it's got to be 8 units of y. And what's my utility? Whichever is the smaller of 8 and 8. Oh, now it's going to be 8. Okay, so which do I prefer? Hey, I'd rather have them give me 6 units of coffee. What does the government prefer? Well, which costs them less. So I put this down here. I like this scheme. The government likes scheme 2. Why? Well, the first case, they gave me 6 coffee for free. That cost them $6. In the second case, they're going to subsidize. They're going to pay half of the price of what I'm spending on coffee. So they're going to pay 1/2 times 8, which is 4. I like scheme 1 where they give me 6 coffee. They like scheme 2 because it's cheaper. All right, and my utility, okay. So that is that. And then I think I said, this is probably why I did this. Yeah, so I want to go up to question 12. All right, so question 12. Ann and Bob face the same prices for income to spend on X and Y. Price of good Y stays the same. Price of good X is designed to discourage large purchases. So it's 1 for the first 3 units, 3 thereafter. Draw the budget constraint. All right, did I draw a picture? I may not have drawn a picture. No, I did draw a picture. Good. All right, so when you have one of these things where the budget, as I said in the video 1, that you may not have seen video 1, though I think you should. So when you have a budget constraint with a kink because the price changes, I would start by pinning down the one that doesn't change. So in this case, it's going to be the price of Y always stays the same. So I'm going to put down that vertical intercept of my budget constraint. Vertical intercept is the income divided by the price of the good. So 12 divided by 3 is 4. Okay, then what you want to do is you want to find the expenditure to get to the kink. Here the price changes after 3. So it's $1 for the first 3, so it's going to cost me $3 to reach the kink. Now, because how much money did I have available? I had $12 available. I now have $9 left over. With those remaining $9 from here, I can buy good Y. I can buy 3 of them. That's going to cost me $9. That gets me to here. Or I could buy, let's see, this costs $9. I could buy 3 more here, and this is going to cost me $9. That'll bring me to this point 6. The slope of this portion is going to be 1/3 because the price of X is initially 1, price of Y is 3. The slope of this part is going to be 1 because the price of X is 3, price of Y is 3. Okay, so that's our budget constraint. Good. It's going to go here. It's going to be flatter than steeper. And now we have to determine where is going to be optimal consumption. Well, look what I did here. So I said, the way I stated the problem is I said, suppose Ann has the following preferences. These are perfect subs preferences. The marginal rate of substitution is going to be 1/200. MUX over MUY. Marginal utility of X is the partial with respect to X. Marginal utility of Y is the partial with respect to Y. These are incredibly flat indifference curves. Then for B, these are incredibly steep indifference curves with an MRS of 300. Right? And so what I did is in green, I drew the incredibly steep indifference curves. In blue, I drew the incredibly flat indifference curves. And so for part B, where we have flat indifference curves, the solution is all Y. It's an alley solution. And the consumer is going to optimally consume at the corner bundle 0, 4. In the part C, it's an all X solution. It's an Alex solution. They're going to optimally consume the corner bundle 6, 0. That's down here. Right? So the reason why I use like these extravagantly flat or steep indifference curves is that there was no question about this kink here. So that you hopefully actually people just stare at this and they say, wait a second, it's got to be the case that that the marginal rate of substitution is bigger than the price ratio. It has to be an Alex solution. Maybe you didn't have to do any further reflection. Same thing here. This has to be an alley solution because you know the MRS is really tiny. All right. Let's see. Oh, I got the answer for 12 down here. So let me do 12 now, even though I said I wasn't going to. So, and then I'll start the next video with 13. Bob's preferences for X and Y can be represented by the following utility function, 2X plus Y. Bob has $24 to spend. PX is 3, PY is 2. Bob always optimizes. Find Bob's optimal bundle. Well, Bob's margin rate of substitution here is 2. MUX is 2, MUY is 1, so MUX over MUY is 2. Right? We know the MRS is 1. We take the partial. That's just the partial with respect to X. That's just the coefficient. I don't know why I drew a line there. I know why I drew a line. I don't know why. I don't know. I know why the line happened. I just don't know why I did that. The line happened because I've got the drawing tool. Right? All right. So this is going to be the coefficient on Y, which is 1. So 2 over 1 gives me my MRS. So relatively steeper indifference curves implies Bob consumes all X. How do we know we have steeper indifference curves? Well, the price ratio here is 1.5, 3 over 2. So indeed, the MRS is steeper than the price ratio. So this is an ALEX solution. If Bob exhausts Bob's budget on X, this is going to be what? 24 divided by 3, it's 8. And then no units of Y. Let me skip down. Was there another part to part 12? Of course there probably was, wasn't there? Yeah, there's 3 more parts. So now assume the price of good X changes. For what new price is Bob's consumption of X and Y both positive? This is a really good question. So remember what we're doing here is we're comparing the slope of the indifference curve with the slope of the budget constraint. There's 3 pictures you get with perfect subs. You can get ALEX solution. That's when the indifference curves are steeper than the budget constraint, so you get all X. You can get an ALI solution. That's when the indifference curves are flatter than the budget constraint, so you get all Y. Or you can get one that lies on the budget constraint itself, where the indifference curves are coincident. The highest possible indifference curve is coincident with the budget constraint. It was proposed in class that we might call this the Butch-Cassidy solution because it's BC. The solution is a continuum along the budget constraint. Anyway, that's what's happening here. So in order to be able to have an interior solution, meaning a positive amount of both X and Y, it's got to be the case with perfect subs. It's got to be the case that the indifference curves and budget constraint have the same slope. Well, the indifference curves have a slope of 2. To make a budget constraint have a slope of 2, what would we need? We would need the price of good X to be 4. To have 4 over 2 is 2. Why? Because I was asking specifically about the change to the price of good X. Now suppose the price of good X changes. For which values are we going to get an ALI solution? Now we need the indifference curves to be flatter than the budget constraints. We need the budget constraint to be steeper than 2. To make that happen, we would need X to be bigger than 4. Then the price ratio 4 divided by something bigger than 4 divided by 2 would be something larger than 2. And then Bob would consume only Y. All right, and you can see question number 13. I'm going to go ahead and stop here. This video is long enough already, but I hope you enjoyed. I'll leave the comments open. Let me know if you have questions. Also watch email for that as well. Hope the video is helpful, and I will see you next time.